Hello, you're welcome to Daha Virtual School. My name is David and I shall be discussing geography of East Africa. In case of any inquiries, questions, and the need of assistance, please contact those numbers. I shall give you the assistance that you require. Today we are discussing about East Africa and landform evolution in East Africa. East Africa has been shaped by different processes, and those processes are majorly classified into two. One, we have what we call endogenic processes. Those are processes that affect only to formation of landforms in East Africa, but are not visibly seen with our eyes. We don't see them taking place, but they result into the molding of the East African landscape. Such processes can include faulting. You cannot see faulting taking place, but you can see resultant landform like Rift Valley. Some include warping that form basins. Then some include volcanicity that forms volcanic mountains. We also have what we call exogenic processes. These ones take place on the top of the Earth's surface, and they include weathering, they include mass wasting, they include movement of glaciers or glaciation, they include coastal geomorphology, interaction between water and the landmass near the coast of a water body. As those are some of what we call exogenic processes. So today we are focusing on volcanicity, the endogenic process. Volcanicity is the process by which ash, gas, and other molten material or magma are intruded into the Earth's crust or extruded onto the Earth's surface under great heat and pressure from the interior of the Earth. Volcanicity with a U, we are saying, is a process by which either magma or lava is intruded into the Earth's crust or extruded. With volcanicity, we are talking about two processes. Lava can cool under the Earth's crust, or it can be extruded onto the Earth's surface. Then we have what we call volcanicity. This is the process by which ash, gas, and molten rock are extruded onto the Earth's surface. With volcanicity, we are talking about one process, extrusion of lava. And here lava is poured out on the Earth's surface to form different volcanic landforms. The interior of the Earth is comprised of two of different parts. We have what we call the inner core, then we have what we call the outer core, and then we have the mantle. Let me talk about those three. The core, inner core, is an area of very high temperatures, and is comprised of heavy rocks that whose melting point is very high, so they are solid. So because of that very hot, very high temperature underneath, it affects the outer core with the same temperature. So even the outer core is very hot, but also has heavy rocks, so they exist in a solid form. But the mantle has rocks that are a little weak, whose melting point is not very high, so they are affected by the heat from the outer core, and they are forced to melt, so they exist in what we call molten state. And this is what now has resulted, that's what now results into formation of what we are calling magma, which is later poured out on the Earth's surface into what we refer to as lava. So we are saying within the core of the Earth, the temperatures are very hot and the rocks exist in molten state. They form convection currents that rise upwards, diverge or converge, and go back to the interior. Have you ever tried to cook porridge in a saucepan? While you are boiling porridge, if you observe it keenly, the porridge seems as if it is coming from under the saucepan, wanting to come out. But at the point, at the top, it diverges and goes back into the saucepan from the sides. That movement is exactly what is happening in the interior of the earth's surface. Now when that happens, it causes it pulls it creates a force on the overlying rocks, and those currents therefore result into the cracking of those overlying rocks of the earth's crust, forming lines of weakness or weak lines through which magma is forcefully extruded onto the surface of the earth, or intruded into the earth's crust. Looking at this small illustration here, we are looking at the earth first on top of the earth's surface, and then we are trying to project on what happens into the interior of the earth. So let us watch it and see what then exactly happens and what causes volcanicity. Okay, that is the mantle where the rocks exist in molten state, and those you're seeing projecting up are like pillars of magma trying to escape out of the earth's surface. So the inner core is there, containing very heavy rocks whose melting point is very high, so they exist in a solid state. So the effect of the inner core onto the mantle causes the rocks in the mantle to melt. Now they try to find a way of escaping because of the boiling, and there you see a diverging force. Okay, a diverging force. So it creates kind of a small line of weakness through which heat escapes. So we are saying it's the process by which molten rock is extruded onto the earth's surface. And now with that, I think we are very sure, and we have seen a summary of how how volcanicity happens. Now while volcanicity is happening, the lava that is poured out comes out in three forms, in three types, or the three types of magma. It is what we call the viscous magma, and this is very thick, or what we call thick magma. This type of lava has a high percentage of silica, around 66%. It is thick and does not flow very far. It is viscous and immobile. When a mountain erupts with this kind of lava, magma solidifies as soon as it is thrown on the top of the earth's surface. It doesn't flow very far. It is associated with violent and explosive eruptions. In most cases, it provides steep and irregular features. So most of the landforms in South Africa, volcanic mountains that have steep slopes, are majorly formed out of what we call viscous magma, and that kind of lava looks like this. it doesn't flow very far. At eruption, it starts to solidify almost from around. Here it is not violently erupting, but it erupts violently. It comes out as lava, as you're seeing it, as magma, but also even sometimes it comes out in form of with particles, with the big particles of rocks along that magma. Then with that we have also what we call intermediate lava. Now intermediate magma, this lava combines both the characteristics of both acidic and basic magma. Intermediate means it is between. It is not very thick, but it's also not very light, so it is intermediate. And normally it results into development of mountains that have gentle slopes. As you see, for it can at least flow from one area to another. It can flow for a distance. As we see, it can flow for a distance. So that is what we call intermediate lava. Then we have what we call basic or fluid magma. This type of lava has a relatively low silica percentage. Okay, it is very fluid and highly mobile. It is able to flow for a long distance before solidifying. Sometimes you may be requested to prepare porridge, and then you prepare porridge that is very light, almost watery. Maybe you had little flour, then you prepared porridge that is very watery. That porridge takes the form of what we are calling basic lava, and majorly this one forms landforms that are flat, like a plateau or like a flood or like a lava plain. That lava is watery, flows for longer distances, and flows towards areas of low altitude, low lying areas. And when that happens, it forms landscapes that include the lava plateau. Apart from lava, other materials ejected during eruption include the gaseous materials such as ash, volcanic dust, steam, as well as solidified rocks from previous eruptions. So that shows us how eruption happens and what takes place when a volcanic mountain is erupting. Indeed, in East Africa, we have had an experience of volcanicity, and if you look at our sketch map here, it is showing us the cases or areas in East Africa where we have cases of volcanicity, and I want us to look at this sketch map that is showing areas that have been affected by volcanicity. In our sketch here, we are seeing landforms such as Mountain Marsabit here in the north of Kenya. We have Mountain Kenya, we have the Yatta Plateau, we have the Kericho Plateau. These are in Kenya, among others like Aberdare, the ranges. Then we have the Longonot Mountain, Suswa, Mountain Chulu. All these are found in Kenya. Then we have Mountain Kilimanjaro, Mountain Meru. These are in Tanzania. Chipengere. We have the Ngorongoro ranges. These are in Tanzania. Then we have Muhavura ranges in Uganda, and Mountain Elgon, Mountain Moroto, and Napak, where we have where volcanicity has taken place in East Africa. I think you're seeing around here, around the Olonyo Lengai, we have what we call explosion craters. Okay, yes. Then we have what we call the lava plateaus, like the Yatta, like the Kericho, like the Usini Gishu. These ones are lava plateaus. So those are some of the things that some of the areas that have been affected by volcanicity in East Africa. I request that we end here today for today. In our next lesson, we shall be discussing about the landforms that resulted from volcanicity. May God bless you. Subscribe to our YouTube, Daha Virtual School, or go to our website www.dahavirtualschool.com. Invite a friend to attend these lessons. Tell someone about these lessons. They are free of charge, so just invite a friend to like and watch. May God bless you.